Optimization problems are key in calculus. Suppose I gave you this series of boxes, and I said, which one is the optimum size, or which one has the optimum volume? The answer is, well, I haven't given you enough information, have I? Suppose I want to find the box with the largest surface area. Which box would that be? Or perhaps I wanted the one with the smallest volume. Which one would that be? Well, I guess the question is, don't they all have the same volume? And the answer, of course, is, well, no. If I were to have a box that is 3 by 3 by 8 and a quarter, that volume would be 74 and a quarter, as opposed to this one over here, which is a volume of 88. Suppose I wanted the cost of the bottom materials to be different from the cost of the sides. Then I have what we have in calculus called an optimization problem. I am trying to optimize one of the characteristics. Now, the general guidelines for solving these problems, and we call them optimization or max-min problems, is first of all, you have to list all of your givens. That just seems like common sense, but it's skipped a lot of times. So you write down everything you are given first. And along with this, you need to make sure you have a picture, because a picture will help. Then you write a primary equation for the quantity that is to be maximized or minimized. We'll look at a couple of geometry formulas. This might be Pythagoras' theorem. This might be the area of a triangle is 1/2 base times height, that sort of thing. Now, you'll be given other information, so you can reduce the primary equation to having one single variable. You may have to have a secondary equation, like the length is twice the height, that sort of thing. Then you're going to determine the feasible domain of the primary equation. Okay, if we're looking at distances, then all lengths must be positive. If we're looking for areas or volumes, again, then all of your lengths must be positive. And then you determine the desired maximum values. Okay, how do we do that? Well, you take the first derivative and set it equal to 0. Now, here are a list of geometry formulas you just need to know. We will, in particular, use the volume of a right circular cone, a cylinder, a sphere, a sector of a circle, the area of a circle, of course, trapezoids, equilateral triangles, right triangles, just the regular triangles. Just make sure you're very familiar with all of these. They're inside the front cover of your book.